Today is kind of a special day. I decided after 2 years to get off my dead tail feathers and correct a situation that I knew was incorrect. Came the way the car came, but I didn't do anything about it because it was good enough. What I'm talking about is on the electric choke. There are two terminals. One is a ground terminal, this one right here, that I'm pointing to with my test light. The other is powered, and I'm showing 10.4 volts, whereas on the battery I should be getting at least 11.4, maybe a little less in this case because the battery has not been charged for a while. But anyway, the reason it's getting 10.4 volts is because somebody wired the electric choke into an easily accessible power source when the engine is running. Down here in the starter relay, we have the large positive battery cable. The negative side of the starter relay goes down to the starter motor. Then we have what's called the S terminal, which is activated when the ignition key is put in the crank or start position and the neutral safety switch is closed, yada yada yada. This only gets power when the engine is cranked over. Then we have the I, the ignition terminal. This one, when the engine is cranking over, when full battery power is sent down to the starter, full battery power is sent through here to the ignition coil. And when the starter is no longer being used, the ignition key is in the run position, we don't have full battery voltage anymore. We have only 10.4 volts. That's because the resistor wire from the ignition switch is feeding the same circuit that the I terminal feeds, except in the case of cranking the engine over, full battery voltage is sent through here to the ignition coil, typically 10.8 volts or a little bit higher. The problem is that by tapping into the ignition side of the starter relay, the electric heater element in the carburetor isn't getting enough voltage to open the choke up as quick as it should be opened. It's enough to open eventually. But what I've taken note of is in this particular vehicle, when I start the engine cold, it takes a little while longer than it should for that choke to come off, and the spark plugs get loaded up because of fuel fouling. Now, I rev the engine a little bit, it clears the fuel fouling out, and the choke eventually opens and everybody's happy. But I decided today is the day I'm going to change that circuitry and not run the I terminal power from the starter relay over to the electric choke. I am going to pull power from a different area. Now there's a few places I can tap into to get full battery voltage when the ignition key is in the run position. One easy place for early generation, first generation Mustangs is to tap into the power side of the windshield wiper motor. It is a fused circuit, I think 20 amp fuse off the fuse block. And if we don't hang too much on there, we ought to be fine. If you start putting a lot of things on there, it could blow the fuse. Another possibility, not on this car, but on stock vehicles, on the carburetor, there will be a throttle position solenoid. I have a link in the description in this video that'll take you there, that'll show you where the wire is that normally goes to that solenoid. In this case, we have an aftermarket carburetor, hence the need for 12 volts or more from the battery to get the automatic choke heater to work properly. And whoever had done the work on this vehicle before has removed the wiring that is normally feeding the solenoid down here. But if your car is basically stock and it's a 1972 or 73 Mustang, you will find in this area a wiring harness with a wire that is red with yellow hash marks. That is circuit 640. It applies full battery voltage to the throttle position solenoid when it exists. If it doesn't exist, the wire is still there, unless, like in this case, someone moved it. So what I'm going to do is I'm going to unplug the wiper motor plug here. That came apart easily because I had it apart earlier, and show where the voltage is. If I can get down here, right there. Now that's showing 10.8 volts because the battery itself in the car is wearing down. I've had it in run position for some time. But what I can do is splice into the circuit either on the positive side or the negative side of that harness. The easier one to do would be the negative side. And the wire I'm after is this red one. That is the one that will give me the voltage I want for the electric choke. So I'm going to go ahead and splice and run the wiring and put conduit around it so it looks nice and pretty, and then test it and then show how well it works, hopefully, when I'm done. Linda is here with me to help, so I'll have her hold the camera as I try to explain what I'm doing. In order to get power from the windshield wiper motor positive circuit over to here, I need to run some wire. Now currently, with our cooling fan relay for the engine, I already have a conduit that I am running a wire through to protect it on its way over there to tap in the power and to power the status LED lights that I have for the fan cooling circuit. So I'm going to try to run this wire through the same conduit all the way underneath this support frame, back across next to the firewall, and up to where I'm going to tap into the circuit. So we'll see how far we get before my iPhone battery runs out.
I'm just going to get your arm, so I'm going to cut it.
Okay. Okay, on the choke side of this wire that I ran, I have already stripped off the tip of the insulation in preparation for putting on an insulated spade terminal that will plug into the choke. So I put it in place and I crimp it. Now some people are going to say you shouldn't be crimping stuff under the hood. Well, yes and no. In a perfect world where I were driving this vehicle in any kind of weather, I would agree. I should be using a solder connection and shrink wrap tubing to keep water from getting in here. But this is a 49-year-old car, and I do not plan to drive it in the rain or inclement weather, so I doubt we'll ever get moisture up here. So I'd rather go ahead and just keep it simple. Now this wire needs to be further secured. Right now it's running through the same conduit as a fan relay status wire. It's going to be anchored underneath this support and way over here, and this will be tapped into the windshield wiper motor power circuit. This segment, I'm going to put more conduit on here once it's hooked up, and I will tie wire it up so it will not be in anybody's way. Meantime, I will unplug the current wire. I'm going to put that inside the conduit, fold it up so it can't touch any metal and cause a short circuit, because that could cause problems. Meantime, I'll plug this in. Heater element. So after I'm done with connecting the other end, I'll fix all this up, make it nice and pretty. Meantime, I can cinch this down and cinch this down and put all that where no one's going to be seeing it too obviously. If it looks like I'm struggling, it's because I am. My left arm is weak because of a pinched nerve issue. So it's a little hard for me to work with my left hand, gripping things. Okay, I'll be going to the other side of the car. Go. I have two different sides of this connector I can put this little tap device into. I choose not to cut into the original main wiring harness of the car. So I'm going to clip into the side of the socket that has the harness going into the windshield wiper motor. So to do this, I found my red wire. I don't know how well that can show, but I have my red wire.
Got it.
And I'm going to put this tap device on there. Now there's two different sides to this. One for wire to pass through, and the other side is an end that is blocked off. So I put this on the through pass, and now I'll grab the red wire that I ran earlier and just feed it up here. Anyone that says this is easy, it's out of their mind. If nothing else, it's tedious. And I put this wire in deep enough to pass through a push-through metal connector. This metal connector is like a blade. When I squeeze down on that blade will cut through the insulation of both wires that I'm trying to work with and make an electrical connection, basically making a circuit available on the tapped side of the connection. A little bit of doing, a couple of cuss words, but I finally got the Scotch lock tap in place, locked down. So now this red wire that I ran for the electric choke is tapped into the far side of the connector for the windshield wiper motor. So now I'll plug this in to the harness of the vehicle. Sorry, my hands are in the way, but they are. Now it's plugged in, but now I've got all this wire down here I need to deal with.
So we need to clean up down here too.
And I'll clean up at the other end after this. So what I'll do is I'll get some of this plastic wire conduit available at most parts houses, parts stores, and I will put it in place and secure it using some more wire wrap, tie wire wrap. Now I've got a couple of wires down here in this area that I've exposed during this effort. So I'm going to try to get them all taken care of at once. So I'll push this conduit down onto the two red wires that I have feeding down here. And then I'll start to clean things up.
It's only on one red wire coming down here.
Yeah, I'll take care of that. Okay. I just want to get down there.
I got you.
And slipped over this end first for right now. So at the end of the conduit, where the red wire has to come out for the windshield wiper motor, I will use my first wire tie to secure it in place. Boy, could this be any harder? Then I'll cut off the excess for the wire tie, as well as the excess for the conduit, or better yet, I'll leave it there. And I'm going to stuff some of these other wires inside the conduit to kind of hide them away and keep them from touching metal. You know what? This won't be thick enough. I need a thicker, larger diameter.
Okay, did you not want the conduit to come all the way down to where the other conduit started? Because it's not meeting.
It's going to.
You're going to slide it?
I'm going to join together, tire wrap them, and the wire inside will collapse to fit.
I see. Okay.
I get down near the end, and I make it nice and tight. The other end is open because this feeds back, so I can go ahead and tie it off near the end of where the wires are inside. Then everything will be nice and secure. And if I need to work on this later, I simply cut the wire ties where they are, and then I have full access to the electrical wiring inside the conduit. I cut off the excess wire wrap, wire tie. If I want to, I can cut off this excess, or I just leave it hang. Leaving it hang with this car is not a problem because it doesn't reach down and touch the headers. But in order to make sure it doesn't touch the headers, I'm going to wire tie it up out of the way. It makes for a little cleaner presentation. By coincidence, there's a small little hole in this cross brace. So someone 53 years ago, when they're designing this car, must have been thinking of me, because that's where I'm gonna try to connect that conduit to using a wire tie. And now, looking from above, nobody sees anything except wire tie. Okay, now I'm going to go to the other side of the car, turn on the ignition in run position, and check to make sure I'm getting the electrical power down to the electric choke I'm expecting to see. Cut. So I finished up all the pretty stuff with the conduit on the other side. Before I do conduit here to clean this up, I want to make sure the electric choke is getting full battery voltage. I've already turned the ignition key into the run position. When I checked, the battery voltage is 13.8, 13.9 volts, 13.9. Anyway, when I checked that before, is a little over 10 volts. Now, if we were to check what the voltage would have been, 12, 13, 0, less than battery voltage, 13.9 now. I go in here and check, and I am now getting 13.5, 13.6, basically battery voltage. A little bit less than full battery voltage because the wiper motor power circuit is going through a couple of connectors between the battery, ignition switch, and the fuse block, and where I tapped. But it is more than the voltage I would be getting out of the ignition side of the starter relay. So I'm going to turn off the power through the ignition switch and clean up this conduit put it all together, start the engine, and see if the choke comes off a little faster than it used to. Yep.